All right, so this unit's all about an AP Calc preview. What we're going to do is we're going to focus on working on derivatives a little bit more. The first thing we're going to talk about with derivatives is just kind of the basic things that we've already kind of addressed, but like formalizing this definition. So we've talked about derivatives, so like the derivative of f of x we labeled as f prime of x. Now we're going to look at some new notation here. We're going to say d of, and then we're going to read this whole thing over dx. That just really means the change in the function divided by the change in x. You can also use delta as a change, but we're typically use d in calculus. So the change in f of x plus g of x over d of x, really what we're saying here is what we've been doing in the previous section. We're just going to take f prime of x plus g prime of x. In other words, if we're dealing with individual pieces of functions and adding them or subtracting them from each other, I guess I should include that minus there, we're just going to take the derivatives of the individual pieces. Now, the first couple of examples aren't going to deal much with that. We're just going to kind of refresh ourselves on how to do derivatives. But once we get down to example really 5, I suppose, that'll be where we start integrating that. Essentially, it's just you have multiple terms. So on number 1, f of x equals 12. And folks, one thing I suggest is, especially in these beginning stages, give it a variable raised to the 0 power. So take your constants raised to the 0 power. Just as a refresher, what we end up doing with our exponents, it's weird circling the number 0. We take it, we multiply it out front, so it's going to be 0 times 12, and I'm going overboard 0 times 12, and I'm going overboard here, times x to the, and we subtract 1 from the exponent. Well, 0 times anything is just 0, so we're just going to give this f prime of x equals 0. Essentially, the derivative of any constant is just always going to be 0. Now, moving on to another one, f of x equals x to the 7th. Again, we're going to take that 7, move it out front, and multiply. So it ends up being 7 times 1, which is just 7. Take away 1 from the exponent, we got 7x to the 6th. So f prime of x equals 7x to the 6th. For number 3, get a little more sophisticated here. We got h of x equals x to the 1 over x to the 5th power. What I want you to think about this as h of x equals 1 times x to the negative 5th. Remember, if your variable's in your denominator and it's raised to an exponent, you can take it out of the denominator and raise it to the negative exponent. So h prime of x is going to be that negative 5 times that 1 x to the, and we're going to subtract 1, so it's going to be negative 5. I'm going overboard here. You do not show this every time, but it's going to be negative 5 minus 1. So we got negative 5 times 1 is negative 5. X to the negative 5 minus 1 is negative 6. Now, we started off with something as a fraction. We converted it to a negative exponent. We're going to do something similar here. So we're going to end up doing negative 5 over x to the positive 6. We're just sort of kind of undoing what we did. So h prime of x equals negative 5 over x to the 6th. Example 4, we're dealing with a radical here, so it might help us to rewrite the radical as an exponent. So I'm just going to leave that that coefficient of 1 on the x. It's going to be 1x to the 1/5 power. So we're going to follow that same pattern. So we're going to do, we're doing f prime of x here. So we're going to take 1/5 multiplied out front. So 1/5 times 1 is just going to be 1/5. X to the, and then we're going to subtract 1, well, I'll just write this out. We'll subtract 1 from 1/5, so it's 1/5 minus 1. So we have 1/5 x, and then 1/5 minus 1 is going to be negative 4/5. Now, we just did a problem with a negative exponent. That negative exponent means we can take that variable and put it in the denominator. So we can actually put it as 1 over 5, that 1/5, times x to the positive 4/5. Now, a quick refresher, kind of working our way backwards. We took a 5th root and made it to the 1/5 power. X to the 4/5 power actually is going to be, let's write this out, 5 times the 5th root of x, and that whole thing raised to the 4th power. Or you can rearrange that just a little bit. So we'd say 1 over 5 times the 5th root of x to the 4th. Either way works. The x to the 4th, or the 4th power, I should say, The fourth power can either be inside of the root or outside of the root. It doesn't make a difference. So we're still working with those rational properties and also the rational properties, but also the irrational properties using the roots. Now, number 5 is when we start getting like multiple parts. We have x, we have 11, but we're going to do the same thing. We're going to do f of x equals, well, this was 1, and so we're going to take our exponent, multiply it out front. So we got 1, and it's going to be x to the 0 because we subtract 1. And this one, remember, constants just become 0. So we have 1x to the 0, which is just 1. F prime of x equals 1. Also, quick context, remember, derivatives, you're finding slope at any point on a line. The line x plus 11 is just a linear graph with a slope of 1. So that at every point on that graph, you're going to have a slope of 1. So that's one you probably could have eyeballed just kind of quickly. Number 6, we're going to get a little more complicated, but not too bad. We're going to do f prime of t equals taking the exponent multiplied by the coefficient. Negative 2 times 2 gives us negative 4. Take 1 away from the exponent, so I'm going to say negative 4t to the first, or just negative 4t. 3t has an exponent of 1, so it's going to be 3 times 1. So we got plus 3. And it's going to be t to the 0. Well, let's just leave, it's going to be times 1, so let's just leave it as that. Negative 6. Well, remember, that's a constant. Derivatives of constants are just 0. So f prime of t ends up just being negative 4t plus 3. Number 7. First of all, it's kind of bugging me that it's written in the order that it is, but whatever, we can deal with that. F prime of x going through coefficient times 2. So we got 1 times 2 gives us 2, and we're going to take away, so it's going to be x to the first. I'm not going to bother writing that. But the next one, 4 times 3 gives us 12. Take away 1 from the exponent, so it's 12x squared. Now I'm just going to rewrite this in standard form. You could rewrite it in standard form to start and then just do the derivatives. I'm just doing it after the fact. Why is this not writing? Sorry. F prime of x equals, putting it in standard form, 12x squared plus 2x. Number 8, f of t. This one's got 4 pieces in it. So f prime of t, coefficient of 1 times 3 gives us 3. T, subtract 1 from the exponent, so t squared. Next one, 5 times 2 gives us 10. Take away 1 from the exponent, so it's t to the first. This one, negative 3 times 1 gives us negative 3, and it's going to be times t to the 0, so it's just going to leave it as negative 3. And remember, the constants cancel out when you take out the derivatives because it's like 8 times x to the 0, so it'd be 8 times 0. Number 9. Now, number 9, I'm going to suggest we rewrite it a little bit just so that way we can take the derivative a little easier. We got x squared minus 4 times x to the negative third. Dealing with the x squared, so we got h prime of x, the derivative of h of x, equals x squared is going to give us 2x. This one we're going to have negative 4 times negative 3, which gives us positive 12. We're going to take away 1 from the exponent, so negative 3 minus 1 gives us that negative 4. Cleaning that up just a little bit more, putting it back into rational form, we got 2x plus 12 over x to the 4th. Put a box around that one. Couple more here. A little more detailed, but we can do it. Number 10, we got f of x equals 4x to the third plus 3x squared over x. Now, before you take a derivative, I haven't really had to address this yet, but it's something we should pay attention to. Before you take a derivative, see if you can reduce some stuff. So like you'll notice this has an x, this has an x, this has an x. We're dividing that numerator, both parts of the numerator, by x. So really, we can just rewrite that as 4x squared plus 3x. Since we're dividing both of those by x, we'll just reduce it. So now f prime of x, we'll just go through and do the derivative of that. 4 times 2 is 8. Take away 1 from the exponent, so it's just 8x to the first. 3 times 1 is just 3. X to the 0, we'll just leave it as plus 3. Next up, f of x equals the third root of x plus the fifth root of x. So let's do this as x to the 1/3 power plus x to the 1/5 power. This is just rewriting f of x. Now f prime of x, we're going to take that exponent, multiply by the coefficient. Thankfully, these coefficients are just 1, so we have 1/3. X to the 1/3 minus 1 is negative 2 over 3. Plus, the next one is going to be 1/5. X to the 1/5 minus 1, we actually did that earlier, is negative 4/5. Now again, since we have negative exponents, we can put those in the denominator. So I got 1 over 3 times x to the positive 2/3 plus 1 over, I forgot I was going to put this as one big fraction, 5x to the 4/5 power. And again, rational exponents, we can convert that back to roots. So we have 1 over 3 times the third root of x squared plus 1 over 5 times the fifth root of x to the fourth. So we can say that is f prime of x. Now again, I mentioned this in the previous example. You can also put that, or the previous irrational example, we're dealing with radical signs. You can also put that exponent outside of the root, so it would be 1 over 3 times the third root of x, that whole thing squared, plus 1 over 5 times the fifth root of x, that part there to the fourth. It does not make a difference. It's just kind of preference of format. Last one, best one. Let's do this. All right, f, thankfully it's already in exponent form. So we're going to take each of these. We got f prime of t. Sorry, my stylus is not picking up there. F prime of t equals 2/3 times 3 over 2. Well, that's just 1. We're going to subtract 1 from the exponent, so you have t to the 1/3. Next up, we have 1/3 times 3, which is also just going to give us 1. Oh, I don't know why I put an equal sign. Sorry. Minus 1/3 times 3 just also gives us 1. And we're going to subtract 1 from the exponent, so it's t to the negative 2/3. And that plus 4, again, that's a constant that just zeroes out. I'm going to write that there, just why not? Cleaning this up a little bit, we got f prime of t equals t to the 1/3, that's the same as the third root of t, minus, oh, scratch that, I made a mistake there. I'm going to go back. When we subtracted 1 from that exponent of 2/3, that should be a negative 1/3, so my apologies. So when we put that as a fraction, negative exponents means put that variable in the denominator, so it's 1 over t to the 1/3 power. We'll clean that up in a second. Minus the next one, it's going to be the same thing. We got 1 times t to the negative 2/3, so we're going to put that negative 2/3. We're going to put that exponent in the denominator, so it's going to be 2 or t to the 2/3 in the denominator. Cleaning that up just a little bit more, we got 1 over the t to the 1/3 power is the third root of t minus 1 over the third root of t squared. And again, you can put that square inside the radical or not. For this, it would be a little complicated to go through and multiply this out to rationalize our denominators, so we're not going to bother with it.